In this conceptual problem, we have two elementary irreversible reactions, A producing a desired product and an undesired product. And we have some temperature-dependent trends in the selectivity of the desired product to the undesired product. So that selectivity is 3 at a lower temperature and 1.5 at a higher temperature. And the question is, which reaction has a higher activation energy? Okay, this problem is pretty easy to reason out without equations, but I'll go ahead and write some equations here. All right, we can write out the selectivity, and this is the instantaneous selectivity, SDU, but we're going to expect the instantaneous selectivity to follow the same trends as the overall selectivity. All right, and that's because the selectivity is not a function of concentration in this case. If we write out the instantaneous selectivity, that's equal to Kd times the concentration of A over Ku times the concentration of A, because both reactions are elementary and therefore they're first order in A. And so they have the same concentration dependence. And the fact that we might have a different overall conversion at 600 K than we do at 500 K over this fixed time will not affect the relative rates of these reactions, because they depend only on K, and the K depends only on temperature, which is fixed in each of the parts of these problems, 500 or 600 K. We can then further express this in terms of a ratio of pre-exponential factors, which is not temperature dependent. Right? And then the other part of the Arrhenius expression would be the exponential of the desired activation energy over RT, the negative of that quantity, times the exponential of the undesired activation energy over RT. And the observation is that the selectivity goes down as temperature goes up. And for that to happen, it means that the denominator has to increase more rapidly with temperature than the numerator increases with temperature. All right, both the numerator and the denominator will increase with temperature, but the temperature sensitivity is determined by the activation energy. And so therefore, the activation energy for the undesired process is greater than the activation energy for the desired process.